In this question, point -2, -8, 6 is reflected in the plane with this equation. What we want to do is determine the coordinates of the image point. So, what we're going to do is draw a line perpendicular to the surface of this plane from this point. Well, the normal vector of this plane is perpendicular to the surface of the plane. That means the vector 3, 7, -1 is perpendicular to the surface of this plane. So we can use that as a direction vector of a line from this point and figure out where that line meets the plane. So the line that we'll use is -2, -8, 6 plus t times 3, 7, -1. And we'll see where this line intersects this plane. So what we'll do is substitute the parametric expression -2 plus 3t in for x, -8 plus 7t in for y, and 6 minus t in for z. Substitute that into the equation of the plane and solve for t. Doing that leads to a t value of 2. So the line with this point and this normal as a direction vector meets the plane at the point 4, 6, 4. Well, what we want to do now is determine the coordinates of the image point. So we've traveled from -2, -8, 6 to 4, 6, 4. And we want to know if we travel this far, what would be the components of the vector if we repeated that again? Because that's all that's happening when we reflect. We take a point, we move it to the mirror, we get a new point, and we then determine the coordinates of this point on the other side. Well, we see that our x-coordinate went from -2 to 4. Well, that's an increase of 6, so we need to increase another 6. So -2 to 4, 4 to 10. So the x-coordinate of our image point will be 10. Our y-coordinate went from -8 to 6. Well, that's an increase of 14. So 6 plus 14 is 20. And that'll be the y-coordinate of the image point. And finally, 6 to 4 is a decrease of 2. 4 minus 2 is 2. So to travel from -2, -8, 6, the original point, to 4, 6, 4 on the surface of the plane is equivalent to then traveling from 4, 6, 4 to 10, 20, 2. So the coordinates of the image point must be 10, 20, 2.